Hello everybody. Today we're going to work on applications of the integral. So if you've watched my previous videos, we've always had a plus c. And some people have asked, how and when could you get rid of the plus c for a more accurate function? The answer is, let's check out some business applications. For example, example 1, we have the marginal revenue is equal to negative 30, parentheses, 2x plus 1 to the negative 2 plus 30. And we want the original total revenue function from the marginal revenue. Well, this is a perfect example of when an integral is needed because the marginal revenue is the derivative, right? The marginal revenue is the derivative of revenue. So I know if I anti-differentiate, that is, if I take the integral of this element, I will be able to determine the original function up to some constant c, which we'll try to figure out in this example how to deal with that situation. So the question is, how do you integrate this expression? Very good question. The answer is you really break it into two parts. You really, at that plus, break it into two separate integrals. You have the first piece, which is a power rule, and then you have the second piece, which is nothing more than a constant rule. See, I break it apart at that plus. I really have two separate integrals, antiderivatives to work with. Integrals and antiderivatives mean the same thing, so I'm just going to say integrals from now on. So I want to integrate this piece. Notice it's an indefinite integral, no bounds, no big deal. So I want to integrate this. Well, this is nothing more than a u sub I've taught you. That is my u. So if I do my integration, it is integral. Negative 30 comes down like before. That turns to u negative 2. And remember, the dx, we have to do our substitution, right? U equals 2x plus 1. And then du equals 2dx, which means dx is equal to du over 2 when you solve it out. Please do all that work to make sure you see how dx turns into du over 2. The other integral, 30, that's easy. The integral came from some function 30x, because again, the derivative of 30x is 30, so that's why I know the derivative 30 came from 30x, plus some arbitrary constant c we got to work with down the road. Still got to integrate this part. Well, my next step is always to pull the constants in front, right? The negative 15 integral u to the negative 2 du. I'll keep this other part in the back of my head. And then, oh, it's a power, and that is not a negative 1, so I do not need the log. So what I can do here is just a good old power rule. That is, and there's a minus. Why is there a minus there? There's no reason for that minus. I apologize, people. That negative's out in front, so there's no reason for a minus. So let's make sure we're clear. So when we integrate, we add 1 to the exponent and divide by that number. I want to be careful I have the right number of negatives in this expression. So that negative comes down in front, so that's a positive there, as in nothing there. And now we have u to the negative 1 over negative 1, and then you resubstitute back in, you get 15 parentheses. What was our choice for u? 2x plus 1 to the negative 1, and don't forget your other piece, plus 30x plus c, and that is so far my revenue function, the TR, the total revenue function. Normally we're done, but the good news is with the revenue function, there's one point we memorize that is always there. See, when you're going to the next part to find C, because that's what's next. Let me pause for a moment. We have integrated nicely. If we take the derivative of this right here, if we take the derivative of this, we should get back to the original function. It's always good to check that. It's always good to check that. If I integrate this, I get to here. If I take the derivative of this, I get to the original function. That is the marginal in this case. The derivative, the original function. Now, Sometimes I talk fast, so I tell you guys to pause it, write it down, let it sink in what's going on. Take it at your own speed and then play it again a few times. So how do we find C? You need a point. You need a point. The good thing about revenue, there's always a point we all know. On the revenue curve, 0, 0 is for free. That's because if we produce nothing, we don't bring any income in. So the point 0, 0 is always on the total revenue curve. This is not true for any other curve. The revenue curve is just very, very special. You'll see in my next example how it's different for like the cost curve. So I have the point 0, 0. What does the point 0, 0 mean? It means if I plug in 0 for X, the revenue should be 0. So this 0 here goes here because that's the Y, right? Total revenue is the Y. This 0 is the X. So I'm going to plug in everywhere a 0 for X. So 2 times 0 plus 1 is 1 to the negative 1 plus 30 times 0 plus C. And now look what we have here. Some good old algebra. What we have is, well, 15 times 1 is 15 plus C because 30 times 0 is 0. So that tells me that C is negative 15. Look at that. All I needed was 1 point on my curve and I can solve for C. And that's all you need. You need to tell me a point about your function, a starting point, an ending point, some point on your curve that I can plug in for X and set for the Y value equal to the function and solve for C. So my total answer here that I'm looking for, if we put it all the way back to good shape, and negative means denominator, we have 15 over 2x plus 1. So that's that piece. 30x. And now I finally have the constant, minus 15. And there is my total revenue function I've been looking for. Now, if somebody wants me to predict the revenue, I can. All I got to do is plug in the units. You want to find out the revenue for 10 units of production? Fine. Plug in 10 for X, calculate it out, and there's your revenue. We can go back to good old Econ 101 and 102 now. We have our revenue function, most often sometimes called the total revenue function. Cool. So we move on from there to what if we have the marginal cost function instead? And let's bring this one down a little bit in difficulty. Let's say the marginal cost is 4x plus 2. And let's say the cost of 10 units is $280. Can I find the original cost function? The answer is yes. What we have here is a marginal, which means we have the rate of change, we have the derivative, and we also have a point in time. We know the cost of 10 units is $280, which means we have a point in time to find C. Honestly, this statement here is all about finding C. What I'm first going to do is realize the cost function, the total cost function, is the integral of the marginal cost. So that's kind of one of those things we just memorize. To find the cost function, we integrate the marginal cost. The marginal is the rate of change. If you integrate the rate of change, you're back to the original function. The great news about this integral, you don't need anything powerful. No U sub needed here. This is just a good old-fashioned split it and do it separately. The integral of 4x is 4x squared over 2. The integral of 2 is 2x plus c. We should be able to quickly find these antiderivatives. The antiderivative of 4x, that's a power. So I add 1, divide by that number. The integral of a constant is a constant times the variable of integration, in this case 2x plus c. Yeah, be careful. Call this cost. Write down cost. You don't want to have c equals c and you cancel out the c's. That'd be bad. Cost equals. Sometimes I don't use c here. Sometimes I use k because what's in a letter? I just don't want to use cost and c and get you guys confused. So the cost function is this plus some constant. Now here's the thing. In the previous question, revenue, we said at 0, the cost would be 0. Sorry, the revenue would be 0. That's not true for cost. If we produce nothing, there's still a cost. It's called the fixed cost. So if they gave me the fixed cost, I could plug it right there, because that's really what this is. Because if you plug in 0, this is 0. If you plug in 0, this is 0. The only thing left is the fixed cost. So if I knew the fixed cost, I could plug it right there. See, these are the variable pieces. This is the fixed cost. I don't know that. What I do know is cost of 10 units is 280. That, though, my friends, is a point in time. For 10 units, it's 280. That is a beautiful point in time for me to plug in. I know that 280 is the cost. I plug in 10. Allow me to take 4 over 2 and make that 2, by the way. 10 squared plus 2 times 10 plus C. So again, 4 over 2 is 2. I hope you can do that math. And we get 210 squared plus 210 plus C. And so, all right, let's simplify this out. We have 200 plus 20, so 220 plus C, and that tells me C is 60, which means I have arrived at my total cost function. It is 2x squared plus 2x plus C, or in this case, plus 60. And once again, now that I have the cost function, I can once again say, all right, so what's the cost of 0 products if we do nothing for the day? If you do nothing for the day, the variable cost is gone. These are both 0. But there's your fixed cost. Notice that. Your fixed cost is $60. To get fixed cost, you plug 0 into the cost function. Now, if you want the cost of 2 units, plug in 2. You want the cost of 10 units, plug in 10. And it better be 280. If you plug in 10, you better get 280 there. Alrighty, on to our next example. So in this example, what I would love you to do is pause the video and try to do this example prior to me working out the work. This is a great way to get ready to see if you are prepared to do marginal revenue and to do marginal cost. So what we have here is marginal revenue, marginal cost. Your fixed cost is $1,000. So your marginal revenue function is 900. Your marginal cost function is here. Your fixed cost is $1,000. We have one question I have on the table. What is the profit function? Can you form the profit function? And now I would like you to pause and try it. And then after, walk through the video with me and see how you did. See where the mistakes are made. Write those mistakes down in your little crib sheet so you know when not to do it again. So again, please pause the video, try it out. What I'm going to do is just continue. So we have profit. First, you got to know profit is revenue minus cost. And so this question becomes, what is revenue? What is cost? So we start with revenue. How do we form revenue? Well, revenue, part 1, we'll call it. Revenue is the integral of marginal revenue, which was 900. Again, revenue is the integral of marginal revenue. So we integrate this, no big deal here. The integral of 900 is 900x, because that's the integration rule of a constant, plus C. We do know we get a point for free on the revenue function, and that's the 0.00. So when you plug that in, you get a revenue function that is actually, well, if you plug in x to be 0 and it's equal to 0, that means C is 0 in this case. And so your revenue function is just good old 900x. So we've locked down one portion now. We have the revenue function is 900x. Again, I plugged 0 in for x and 0 on this side and solve for c. C is 0. That happens. Sometimes the constant is 0. Second step, we need to come up with the cost function. Well, the cost function is the integral of marginal cost. Now, I hope you pause and you tried this part out. The marginal cost, you got to be careful because the marginal cost was a square root. And when I see a square root, I don't care if it's integration or taking the derivative, I write it as a power. That's very important. Whenever you're integrating or taking the derivative, you're going to want to write your square root or any root as a power. Please notice I now have a parentheses power, and that drums up to me the U sub. So I'm going to jump ahead in this game and get us to the answer, but I hope you can bust out the U sub, take, steps down, right? Bring this down. This is going to be U, but then you're going to add 1 to the exponent, so it's U to the 3/2 over 3/2. But you're going to have this piece du over 1 in this case, so no big deal. So please check out all the details of why I got each one of those. I'm going to simplify that out. My cost function, well, I got 30 times 1 over 3/2. So you flip the 2, divide by 3. Oh, what do we get there? We get 20. U, well, we already decided what U was, x plus 4 to the 3/2 plus some constant. That's our cost function. And if I take the derivative of this, 3/2 down, boom, gives me 30. Leave the inside alone, subtract 1, gives me the 1/2. So I know the derivative of this matches this. So I know my integration by U sub worked perfectly. Now what? I need a point. In this case, 0, 0 almost never works. You need more information. And they told it. They said the fixed cost was 1,000. Well, the fixed cost is 1,000 is the point 0, 1,000. Fixed cost always happens when x is 0. Quantity is 0. So I'm going to do the algebra now to find the c by plugging in 0 for x and setting it equal to 0, because that's the output you're looking for. So again, the output, the $1,000 cost, okay, the $1,000 cost comes if we do nothing for the day. So we plug in a 0. Now I got to do some math. Square root of 4 is 2. 2 cubed is 8. 8 times 20, what is that? I believe 8 times 20 is 160. And in fact, I'm going to get my calculator out so we don't make any silly mistakes there. 8 times 20 is 160. Sweet. I can still do algebra. Now we're going to subtract over, and we get 840 when we subtract. And so there's my constant. So my cost function is 20 x plus 4 to the 3/2 plus 840. There is my cost function. The second piece. Again, what you should do is pause this video and write down these step by step till you see how I did these. If a U sub is bugging you, please go back. I've done 2 videos on U subs. Check them out, guys. Check out the U subs. I do the same technique over and over. The only thing I'm adding from the previous videos is, what do you do with a constant? The answer is you integrate, and then you use the point, the initial information, the initial boundary, you plug it in and solve for your constant. All right, to find a constant, you need an initial point. How do you get the initial point? You got to read the question. In this case, it said the fixed cost was 1,000. Fixed cost is when x is 0. You have to just know that. That's just a concept from econ. Fixed cost is when units are 0. So 0, $1,000 is what that is. So if I wasn't correct, that's $1,000 up there. I still want to find profit, so we're almost done. It's revenue minus cost. Revenue is 900x. So I now know my profit function is 900x minus this whole enchilada. So it's this piece, and if you're minusing, both pieces get minused. That's good algebra. If you're minusing cost, both pieces get minused off. That's called good algebra. So there is my profit function. Now, what do you want to do with the profit function? It all depends. Do you want to find the marginal profit? All right, take the derivative of that. Do you want to find max profit? Because that's usually what you do, right? Is once you get the profit function, you want to know, well, A, where do you break even? So you can try to find break-even points. Or the big enchilada, the big one, how do you find maximum profit? Well, to find maximum profit, you would take the derivative of this and set it equal to 0 and solve. So if I wanted maximum profit, I would take the derivative of this thing, which I'm doing pretty quickly. Derivative of 900x is 900. Derivative of this is a chain rule. Bring the 3/2 down. Oh, what do we get there? We get 30. X plus 4 to the 1/2. Derivative of the inside is 1, so I can multiply by 1. That's a good chain rule. Derivative of 840 is 0, so now there's your derivative. We will set this equal to 0 because that's where critical points occur, and then we solve. All right, how would I solve? First, I would pause this video again and try to solve it without me, but I'm going to add this piece over, right? What am I doing here? Well, I'm moving on to another portion of the question. You don't have to do this portion unless asked for. I just think about the fact, if I was given this information right up top, what is the key goal? Probably to find maximum profit. Usually that's what we do in business. We either find one of two things, break even or maximum profit when it comes to business, or the marginal. But they all involve the profit function. So three big things, right? Big break even, marginal profit, so you see growth or decay, or maximum profit. How do you do that? First, you have to form the profit function, and that's what all this work did. All this work did so I could do revenue minus cost. Once you have revenue minus cost, you can find maximum profit like I'm doing. Maximum profit is the derivative. So there's the marginal already. Look, I got the marginal. The derivative equal to 0. How do I solve that? Well, algebra time. Move the 30 over, divide it back, so I get 30 equals square root of x plus 4, because that's what 1/2 power means. Right? Divide over the 30. 30 times 30 is 900. How do I get rid of a square root? I square both sides. So 30, I know that looks like a 302, so I'm going to erase that. 30 squared, 30 times 30 is 900. Feels like we're going back and forth. X plus 4. And then we subtract over, and boom shakalaka, we get the units needed for maximum profit. If we sell 896 units, we should hit a maximum profit. And to be clear, we should really do our derivative chart just to make sure that I didn't accidentally find something else. You know, pick a point prior, like 800, pick a point after, like 1,000, plug it into the derivative. Here's my derivative. Plug in a number like 800. That's going to be too small, so it's going to be positive. After, it's going to be negative because 1,000 makes that big and makes that more negative. And so we truly have an increasing and decreasing point, which means this is a maximum. And so what we have here is we found the best possible situation for our company. Produce 896 units, and that'll be the best thing possible for our company, because that's when we will achieve maximum profit. Now, that is not profit. You got to be careful, right? That is not profit. That's just units. You want profit, plug this back into profit, and you'll find it. All right, guys. Thank you for watching my examples of how to find the value of C. Stay tuned for future videos.